I'm Deepa.
I'm Deva.
I'm Sam.
I'm Olivia.
I'm JC.
Our topic is AC/DC, and this is an assignment for Dr. Kate Davis's Issa 340 class at Texas A&M University, fall 2022. AC/DC are an Australian rock band formed in Sydney, New South Wales in 1973 by Scottish-born brothers Malcolm and Angus Young. Their music has been variously described as hard rock, blues rock, and heavy metal.
Bill Nye, you dummy. That's not what we're talking about today. You know what? We'll take it from here.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy. Bill.
T minus 7 seconds.
Bill Nye the Science Guy.
AC current, or alternating current, is a type of electrical current in which the direction of the flow of electron switches back and forth at regular intervals or cycles. Current flowing in power lines and normal household electricity that comes from a wall outlet is alternating current. The usual waveform of alternating current in most electric power circuits is a sine wave, whose positive half period corresponds with positive direction of the current and vice versa. In certain applications, the guitar amplifiers, different waveforms are used, such as triangular waves or square waves. Audio and radio signals carried on electrical wires are also examples of alternating current. These types of alternating current carry information such as sound or images, sometimes carried by modification of an AC carrier signal. The standard current used in the US is 60 cycles per second, which is a frequency of 60 Hertz. In Europe and most other parts of the world, it is 50 cycles per second, which is 50 Hertz.
DC stands for direct current, a kind of electrical current characterized by the unidirectional flow of electrical current. In direct current, the flow of electricity is caused by electrons moving in one direction from positive to negative poles. Direct current is opposed to alternating current, a kind of electric current where the direction of electric current periodically alternates. Direct current is useful because it can be used to store large amounts of electrical energy for later use. Most batteries, fuel cells, and solar panels produce DC electricity. DC currents are also mainly used to charge devices because most batteries are built to charge and store direct currents. The first kind of commercially available electricity was direct current, spearheaded by inventor Thomas Edison. Direct currents can also be used to send high amounts of electrical energy for distances with comparatively little energy loss.
Alternating current is mainly used in the industry of transportation and production of electricity. In fact, almost every household in the world is powered by AC. DC is generally not used for these purposes due to the more power loss to heat compared to AC, higher risks of producing a fire, higher costs, and issues with converting high voltage and low current to low voltage and high current using transformers. We get AC power from outlets like this, which can be used to power all sorts of devices, like this waffle maker, or this refrigerator, or this washer.
So we know that AC power comes from outlets and is delivered through transmission lines, but did you know that most devices use DC power? What sort of devices use DC power? Well, lights. Your mobile phone. And laptops. But you might be wondering, how does AC power convert into DC power? Magic.
I don't think so. Want to know how AC is converted to DC? Let's draw a graph and see exactly what we're trying to do. We want to make a circuit that has an AC input and a DC output. Let's take a look at what type of circuit can do this. This is a half-wave rectifier. We have our sinusoidal input voltage, our diode, and our output voltage resistor. We want to take a look at the inputs and the outputs of this circuit. As mentioned before, this is our input voltage. But what happens to the output voltage due to the diode? Well, the diode can only conduct current in one direction. So during the positive half of the input cycle, we'll have current conducting. But during the negative half, the current can't flow the other way, so we won't have any voltage on this resistor. So, because of the diode, we'll only have voltage across the resistor when the input voltage is positive. Lastly, if we add a capacitor in parallel with the resistor, we can see that the output voltage will smooth out just like this. Now, we have an output voltage that's close to a DC output. Now you may be wondering, where do we really use this? Well, a rectifier may be a lot closer to you than you think. Let's look at my bag. I've got my handy dandy rectifier right in my bag, my laptop charger. So what happens is, when you plug this into the wall, you get an AC input coming from the outlet. Then, this is a rectifier. So when you plug it into your laptop, it gets converted into a DC output. That way your laptop can charge. Wow, I really learned a lot today about AC versus DC power and rectifiers. Thank you so much, Deepa, Deva, Sam, JC, and Olivia. I appreciate it.